Hi, we'll continue our discussion on life table approach or discrete distribution. But in this section, what we will try to look at is a fractional age. What if the age is not 2, 3, 4? What if it's like 2.6? So let's take the example that we looked at last time. So we looked at simplified example last time, and if you can remember, we started with time 0, we said time 1, time 2, 3, 4, and we started with a cohort of 1000, right? And this is, remember, this is LX. So we started with a cohort, tracing a cohort of 1000, and we said in the first period we have 20 death. So D0 equal 20, and then in D2 we have 80, then we have another 10, so move to 970, so this is 10, and then let's say we have also, let's say, another 12, so, and then we have 16 death. So if we trace this cohort, and then we'll have 958, and this is 942. So this one, we looked at it last time. We defined what is the 1000 here. It's just like, if you remember, this is L0. This will be L1, or cohort at time 2 at the beginning of second period, and this is L3. This is L4, just to remind us what we did, right? And this is the D1, D0, D1, D2, the depth between the two periods, right? So let's just, this is a reminder for us what we did last time. But now what we wanted to introduce is what will be the cohort in a fractional period. So let's say what we are looking at here, instead of, you know, the cohort at time 2 or at time 3, or at time different time. So let's see, what if you wanted to have it here, 2.6. You know, this is like, I put it here as 0, but it can be 60, like what we did last time, 61, 62, right? So let's say we are interested in, let me use different color, 62.6. What is the cohort here? What is L62.6? Right. There are two assumptions to compute this one. Two assumptions we use. One is we can compute the fractional age using the uniform distribution of death, or uniformly distribution of death. We will use UDD, and this is not the same uniform distribution we looked at. That is different thing. That's uniform distribution for the life random variable, but this one is an assumption to compute fractional age. So it's not the same uniform. So the word uniform, it tells us that you have the death and you distribute it uniformly equally over the period. So I mean, you can just, using logic, we know like L62.6, using just simple logic, you don't need really to make much here, is you say what is the depth between the two periods, which is 12, or we say we take at the beginning of the period and you subtract from it the depth that is occurring in the first 0.6. So you take 0.6 multiplied by the depth of 12, right? Because the idea here, just if I want to use a different color here, so we want to distribute this 12 to this and this, two periods, right? So you wanted to distribute the depth here is between this and this. So if you take the 12, you divide it, multiply it by 0.6, right? 0.6 multiplied by 12, what you get is 7.2. So you can put 7.2 death here, and then the remaining will be 4.8 here, right? So the death can be like, you have two periods here, 7.2 and 4.8. So we take from the 970, we take the 7.2, which is 970 minus 7.2 2, which is the share of death for the first 0.6 of the year. So we have 962.8, right? So 962.8 is L62.6. I mean, this is, you can do it logically, right? You can do it logically without any rule. But if you wanted the rule, the generalized rule, so instead of having L62.6, we will have, let's say, Lx a plus, let's use a small s here, and s, let's say s fraction of a year. So it's a fraction of the year. So x is the not the fraction, it's 2, 3, 4, 5, 50, 60, and then we add s is the fraction. So this one, what we did under uniform distribution, under UDD, what we did here, you take Lx, L at the beginning of the year, and you subtract from it s multiplied by d of that year, right? Simple. And this is, you can, memorize it, or you can write it also. Lx plus s is equal to Lx minus s, Lx minus Lx plus 1, right? All of them, they give you the same, I mean, just like different notation, but the same logic. I wanted to take this one here, take it further. Divide both sides by Lx. So you have Lx plus s divided by Lx equal, Lx by 1, Lx will be 1 minus s multiplied by dx over Lx, right? And this is another formula, you can memorize it, but this one can be simplified. If you remember, what is Lx plus s divided by Lx? This is simple, it's s survived x, right? For x to survive s, right, is equal to 1 minus s, I mean, this should be small s, right? S multiplied by dx over Lx. If you go back to the previous lesson, you would know that this is qx. This is very important one as well. Similarly, I mean, you can take sx, I mean, this spx is 1 minus s, not multiplied, sqx. This is not multiplied like for a life reach the age x, what's the probability of dying within s period, right? So if you compare this with this one, what we can get is sqx is equal to s multiplied by qx. This is very, very important. What this one, it says, you need to be careful about how we're reading it. I use parentheses just to say it's multiplication. To differentiate between this and this, to differentiate them, I use parentheses. So what here, the first term, what this one tells us here, this is the probability for a life that reach just turned into x, so the life turned x, just turned x, exactly x. What's the probability for that life to die within s? And s is a fraction of a year. What's the probability for it to die within s? Under UDD, this is only under UDD. All of these formulas under UDD. Under UDD, uniform distribution of death, it's SQX as life to survive, life age x to survive to s. No, not to survive, to die within s period is equal to s period multiplied by the death occurs within the whole year, right? So this is what this one tells us is s, the fraction of the year, 6 months, 7 months, like 0.6, 0.2, 0.3 multiplied by death. This one, death occurs over the whole period of the 1 year, the whole 1 year, right? And that's why we say uniform distribution of death. This is very important. This one is also very important as well, right? Everything I put here very important. Another Another interesting also formula for uniform distribution. What is, remember mu? What's mu? If you remember, mu is the force of mortality. We know what's mu x. Mu x is, if you remember, is the derivative of x minus divided by s of x. Right? But what is mu x plus s? You know, what is the force of mortality at time x plus s? If you remember, I mean, we looked at the mu x plus t is, we said also d dt of tpx divided by tpx. And this t here is like x is the age and t 1 year, 2 year, you know. But here s, we are using the same logic here, but we are using fraction of the year. So this one, we apply the same rule here, right? So it will be the d, but instead of dt, we'll use ds, right? Because we have s here, not t. spx divided by s, not multiplied here. Px is not multiplied. We cannot multiply it spx. We have to use the formula here. Now we're gonna use this formula here. So mu x plus t, s. If we apply the formula, we derive it a little bit above. Now this one will become d ds multiply 1 minus s multiplied now qx divided by 1 minus s qx. If you do this one, mu x plus s now becomes, if you take the derivative of the first one, will be qx, because now we're taking derivative to with the subject to s. So this is multiplied qx, it's the here qx, it's a constant, so it will multiply by this, becomes a constant, it's minus, we have another minus here, it becomes qx, 1 minus s multiplied by qx. And this is again under the UDD, right? So you see what I followed. I applied these rules here, this rule and this rule, to derive it here. So again, in actuarial math, notations can be confusing. You have to review quickly and do the problem sets that I post for you guys. The more problems you do, the more you practice, the better you are. Let's take one example just to move from the notation to understand what we have done so far. We are interested in seeing, let's take this one. Let's take a k. K is an integer. Qx. Let's make it q0 just for simplicity. Is given by a function of 1, k plus 1. And for k equal 0, 1, all the way to 4. What's k? K is integer. And what is this line here? Remember, they said this is the deferred period, right? K is the deferred period, and we don't have anything here. We know that there is a 1 here, right? There is 1 here that is, we don't need to put it because it's the standard that if there is no 1, we assume that there is 1. So this is the mortality, you know, like mortality follows this one. The question is to find 2.25 P0. Right. We'll start with UDD. Want you to remember UDD here is we using S. Right. Everything here S. It's not, there is no it's everything here is what we define what's S. S is a fraction, right? So if it's more than a year, then it's different, right? So we focus on the fraction here. Okay. So now, because we have a fraction and we have a year. So we need kind of split it. So how we can split it? Like here, if you look at it, 0, 1, 2, 2.25. We'll take you know, like different. We'll take two different methods. You know, we didn't take the other method, but we'll talk only UDD, but we'll do it in two alternatives way. One way, and then I'll show you a shortcut. One way we'll use the formula, and then I'll show you like how I will do it, so I can do it quickly. So now 2.25, like a life at age 0 to survive to here. It means this life can survive to P0. So the life now survive to here first, and then survive another quarter year. And this, they have to be together, because you cannot survive unless you survive both of them. So it's and because it's and, it's independent, so multiply. And P2 now with the fraction. And why we did this? Because the formula for UDD is dealing with fraction. S is fraction. So now we can get this one and then get this one. Let's start with looking at this function. Now Q0 is given to us 0.1, K plus 1. So let's look at it. Q0. Let's take when K equal K. If K is equal 0, right, because it tells us K bit 0, 1, 2, 3, 4. It's integer, it's 0, 1, 2, 3, 4, 5. No, not 5, 4, right? So if this becomes 0, Q0. But 0, Q0, simply the deferred period is 0, right? So there's no deferred period. So this one we can write it equal to Q0. And what is it? Is you put in K, replace it with 0, then it becomes Q0 equals 0.1. And this tells us P0 equals 0.9. Very good. So we need two P0s here, two P0, then this one can be written P0 multiplied by P1 multiplied by P2.25, right? Because you need to survive to here, and then survive another quarter, right? So we got the first term. Now let's use K equals 1. If K equals 1, 1 Q0. Now we need to look at this one, what it means, this one. This one, it looks like this. You are here at time of 0. You have a deferred period of 1, so this is deferred. And then death occurs within a year. So death occurs here. For you are here. So this one, if you would think about it, how this one will look like. This one, it means that you need to survive first year. So you need to survive P0. So now you are here. And then you multiply it by Q1. Right? This is the definition of it. But P0 is 0.9. And this is, if you plug in 1 here, 1 plus 1, 2, multiplied by 0.1 is 0.2, right? This is 0.2, right? I just plug in 1, right? Now let's look at how we can compute this this one. But we remember this is 0.9. So now Q1 will be 0.2 divided by 0.9, so 2 over 9, right? If Q1 is 2 over 9, then P1 will be 7 over 9 because they are complement, right? This is good. So we are moving in our answer. So we got this. Now we need P2. Now let's say we take another one. Now 2Q0. This, if you visualize it, now when K is 2, we take K equals 2. You are here. So you are here and you wanted the death occurs between 2 and 3. Right? This one you can write it as, now you survive 2p0. Let's write it this way. You survive p0, then multiply by p1, survive here, then survive here, and then death occurs between 2 and 3, so q2, right? But let's see what we have here. Now we have this one is 0.9. Let's put it 9 over 10. P1 is 7 over 9. Q2, we don't know it, and this one is equal to, now you plug in the 2, the k equals 2, you plug it in here, right? 2 plus 1, 3, multiplied by 0.1 is 0.3. Okay. So now this cancel out with this, so it becomes 7 over 10, and then 10 over 7, right? Then you can take a q2 and then p2. Then if you do that q2, so 3 over 10 equals 7 over 3, so we don't need calculator, so it will becomes 3 over 7. And this will be 4 over 7 if we need it, right? Does that make sense? Right. So now let's go back to what the question asks us. The question asks us to have 2.0. I need to change the color. 2.25 P0. And what we said, this 2.25, we can do it into P0, P1, right? Or let me, yeah, and then then we do it 0.25 Q2. Sorry, P2, because this is P. Let's take these guys. These guys, oh, let me use different color. Let's take these guys separately. P0 multiplied by P1, we already calculate them, right? P0 multiplied by P1, this one is 7 over 10. Now let's take this one, 0.25 P2. This is not multiplied, the 0.25 is the s, the small s, but we know the rule is this one will be minus, remember the rule we said, it's SPX is 1 minus s multiplied by qx, right? So this will be 1.25 multiplied by q2, and this one, what is a q2? 1 minus 0.25 multiplied by q2, already 3 over 7. So let's do the calculator. 3 over 7 multiplied by 0.25, and you have 1 minus it. Right. Now this one, but now if you, then this one, we get it up here, right? So let me use the other color. So 2.25 px is 7 over 10. I hope I didn't make a mistake, but let me see. So the answer is So 2.25px is this one. And it's simple. You follow the rules. You need to be careful, and if you understand what you are doing, you should be doing very well, right? Let me take alternative way. Alternative way, what we are calculating is to calculate 2.25px under the same method, UDD, but we'll use alternative way. Remember the question that we looked at, what is given to us, Q0 is, if I can remember, Q0, well, I can go back. Actually, it was given to us, yeah, I remember. It was given to us K, Q0 is equal 0.1, and this multiplied by K plus 1. For K equals 0, 1, 2, 3, 4. The alternative way, I'll tell you this is a trick. You can use it, it works. It's very good, it's easy, and you don't need to use formulas. And just use common sense. Now you are here, 1, 2, 3, 4. And you wanted this one. We don't understand what is this one, 2.25, right? So we remember 2.25 px is equal to like L 2.25 divided by L0, right? So always you take the cohort survive here, you divide it by survive here. But we don't have cohort. We don't have cohort. Well, it's simple. And this is L0, it's not 10. We don't have a cohort. Now, just because you don't have cohort, it doesn't mean you don't create a cohort. You create a cohort at 0 of age 1000. This is L0. And let's see what happens to this. Let's see what happens to this cohort. Right, just put a number, 1000, 10,000, 500, 200. I usually use 1000 because it's easy to handle, right? So if you create this one, and now let's trace what happens to this one based on this one. Now, remember we said K, 0, 1, 2, 3, then you have K, Q, X. It will, if 0, this will be qx, this will, right, we did it here actually, we don't need to calculate it one more time. But actually we don't need to do anything related to this one. Just let me show you how we can do it. Now, if you plug in 0 here, because k is 0, if you plug in k is 0 here, first period, if you plug in 0, this will be 0.1. The depth will be 0.1. So if the depth is 0.1, you start with a cohort of 1000. How many will be dead? 100, right? So now, because we know that this one is, we're using this formula, right? So 100. How much is left? 900. Right? Straightforward. Now, you are here. This is what it tells us. What is now, if you k equals 1, it tells you are here, you plug in 1, it will be 0.2. So you are here, based on you are here, what is the probability of death here? Well, it tells us it's k1, then kq0 is 0.2. So this will be 0.2 now. So the death, because 0.2 of this, it will be 200, right? If you do the same thing here, will be 300, the death, right? So if 200, this will be now 700, and this will be 400. Yes, if I plugged in the numbers and I got this one, just try to work it out yourself, right? So I used an arbitrary cohort at the beginning of the year, and I applied this mortality. This is what I got. So now but you need now for this formula here, You need L.2, we need this one now. Well, which is L 2.25. Remember what we said. You look at the death that happens between these two periods. So if it's all of it 300, what is the death here? And what is the death here, right? So quarter of the 300. So it means that we have 75 death here, and 300 minus, well, 225 here, I mean, 225 here, right? Because it's uniformly distribution of death, right? It's simple. So now L is 700 minus 75, 625. But this one here, 2.25 px is equal 625 divided by L0, which is our 1000. Which should give us exactly the same answer, but this one without, using formulas, using common sense, right? 625, and you can compare it with the same answer we got here, right? It's the same thing, right? So I usually use this method. I like to visualize it, conceptualize it, and move on, but you can feel comfortable to which method to do. But you can practice also this one, what I did here, log in the k, exactly what I did here, instead of repeating what I did here on the table, right? You can practice it and make sure that you understood like where the 100, 200, 300, where it came from, right? So remember, let's now pause and reflect a little bit. We started, this session today, we started looking at fractional ages. How we can calculate, probabilities for fractional ages, especially that you remember the life table I shared with you that last time, it doesn't have fractional ages. So what if you are asked a question, instead of age 60, you ask for age 60.3, right? It's not in the life table. So how you can do about it? We said we use uniform distribution of death, right? Exactly what we did. This is one. So we interpolation. So fractional ages, we do interpolation. The second, using UDD, the second method is to use constant force of mortality, right? Second method is we try to use constant force of mortality. And this, the second, is the constant force of mortality. It does not assume death is uniformly distributed, but assume that the force of mortality is constant. Remember, what's the force of mortality? It's mu. So mu x is equal to mu x plus s. What is s here? S is the little fraction, the 2 months, 3 months, 0.2. It's equal to mu. It's constant, right? Once you find one of them, it's mu, right? It's constant. There is nothing, it's constant here, right? So this is very easy. Why it's very easy? Because under this one, let's say you have px for 1 year, right? You have px for 1 year. We don't write one. We know that px, to survive is e minus mu, right? We don't worry about the s because all the force of mortality is constant. So if you find any one of them, it's the same. So, right, because it's the one with the x or x plus s, it's the same force of mortality. So let's assume that's for 1 year. It's easier, right? So now if you take ln of e, we want to find the mu. So mu, if you take ln of e minus mu, is equal to ln px, right? This cancel out. So mu is ln px, right? It's very good. So once you find mu, then you can compute many other things. But what you can recognize here is also very easy to understand it also, is that px, if you wanted like surviving, px is equal to px raised to s, right? It's driven directly from this relationship. right? So what I wanted now to do is to try to take one example to help us to understand. The one example I wanted to do is imagine Qx is equal to 0.02 and the question is to find 0.4 px, and the first one is under UDD. So under the uniform distribution of death we wanted to find 0.4 px. This is not multiplication, this is like to survive for a life age x to survive 0.4 years, right? And this is simple. Under UDD is, remember what we did, is px is equal 1 minus SQX, so 0.4 multiplied by px, right? So this one will be 1 minus 0.4 multiplied by what is the question, 0.2, and what is this one will be 0.008, so it will be 992, right? Remember, under UDD. But let's try to find it also under constant force of mortality. Want to find it under constant force. So assuming constant force. And simple, for px is equal to px raised to 0.4. And px is, if qx is 0.2, then px will be 0.98 raised to 0.4. So let's do it. This gives me 0.99195. Now I wanted you to compare between both of them. This one is bigger, right? This one is bigger, and this is very important also for us, since that one is bigger, is to know that px under UDD is bigger than SPX, assuming constant force. So, and this is very important to know, like if you are trying to find fractional age, survival using fractional age under constant force of mortality will be less. And simply because we already draw this one, but we'll draw it between 0 and 1, right? This is SPX, and this is age, right? 0 and 1. So if you're using this is UDD, uniform distribution of death. If you're using, actually I should say greater or equal, because it can be equal at the beginning and at the end. So this one will be like this. This is constant force. Yeah, we already talked about it last time, but let's take another example here, a quick example. The other example I wanted now to do is, let's go back to the same one. Qx is 0.2, but instead of asking us to find survival or px, maybe we'll be asked to find the mu. What's mu? Is force of mortality, x plus 0.4. And 1 under UDD, assuming UDD, so mu x plus 0.4 is equal to, we need to remember it, it's equal right away, we know the formula is qx 1 minus s multiplied by qx, right? So our qx is 0.2 div 1 minus 0.4 multiplied by 0.9 multiplied by 0.02. And this one, if you do the calculation quickly, I'll start from the denominator, 0.4 multiplied by 0.02, 1 minus it, and flip it over, multiplied by 0.2. Right. Now this is the force of mortality, but what if we wanted to find the force of mortality of the same one here, x plus 0.4, assuming constant force? Well, if you assume constant force, it's straightforward, because mu x plus 0.4 is equal to mu, and the mu, already we took the definition, it will be ln px, right? Minus ln px, right? If you do that, so we have minus ln 0.98. If you use your calculator, it will be 0.202, right? Right, so with this we finish this session on the fractional ages, what we do with fractional ages. In another session we'll do a few other important aspects as well in life table approach. All right, see you again. It's not the closing.